for me to be able to participate in the conference, although I'm having to do it electronically and very remotely. But anyhow, I bring you greetings from Canada, and I'm going to take my time to talk to you about the Logra model of the Canadian economy. Let me begin with my first slide by putting this model in context. It's one chapter in a book that I wrote called Managing Without Growth. And so I want to explain the overall argument of managing without growth, and then I'll turn to the model in particular. So when I began thinking about the growth question, I encountered arguments which are now, I think, much more familiar than they were about 10 years ago when I began to work on this project. And the question that I addressed is whether growth is possible over the long term, and identified three main reasons why this may not be the case. The first is a concern over the sources of energy and materials required to support economic growth. Much of the focus over these past few years has been on the availability of cheap fossil fuels, but there's also concern about other minerals and our ability to continually access them, and in particular to do that in a way that's not unduly damaging to the environment, and I think that remains a major challenge. Then the second set of concerns revolves around the sinks into which we dispose of the waste. When you think about an economy as I do, you think of it essentially as a flow-through operation. All of the materials that are brought into the economy and on which the economy fundamentally depends are ultimately removed from the economy and disposed back to the environment as waste. So the more we bring in, ultimately the more we dispose of. And most of the materials that we bring into the economy are disposed of within less than a year. Only a small proportion is allowed to accumulate, and eventually even that is generally discarded as waste. Well, this process of extracting materials and disposing of waste and overstretching the capacity of the sinks to absorb the waste can interfere with the capacity of the biosphere to provide us with the wide range of ecosystem services that we now recognize, and on which not only our lives, but the lives of all living things on the planet depend. So there's this set of concerns that the economies of the world have grown to such an extent that they are stressing the capacity of the biosphere to sustain further economic growth. But let me say before I go any further that I'm very much aware that the growth that some countries have achieved, such as Canada and Australia, other Western countries, remains the envy of many other countries, and they are striving, with some justification, to mirror the successes that we've had. I think one of the thrusts of my argument is that it's now time, probably long overdue, when rich countries like ours should be setting a very different kind of example for other countries to follow. The second line of argument as to why we should look at managing without growth is the mounting evidence that beyond a certain what you might call fairly reasonable material standard of living, it turns out that any further increase in the material standard of living doesn't seem to make people any happier. I think the reasons for this are fairly well understood, and that is that we seem to be attaching more and more significance to our relative position in society rather than our absolute level of well-being. And of course, with economic growth, you can't increase everybody's relative position. And so that's the main reason why I think economic growth, particularly in rich countries, is not showing a positive relationship of any significance with happiness. And the third line of argument that I explore in the book is I look at the historical record over the last 30 economic growth. The record is not very encouraging in terms of how it's helped us deal with poverty, what it's done in terms of allowing us to have a more equal income distribution and wealth distribution. Of course, we've seen quite the opposite. What it's allowed to happen with greenhouse gases, and so on. And so the record hasn't been what we might like it to have been. So this led me to explore what might be possible in an economy that wasn't growing. And for this purpose, moving to the next slide, I designed a simulation model called Logra. Now, the focal point of Logra, when I'm talking about growth or no growth, is GDP, or sometimes GDP per capita. I want to make it clear that I don't think that GDP ought to be the primary measure by which we judge the success of our economy. I'm sure many of you are fully aware of the inadequacies in GDP for that purpose. However, in the model, I do focus on GDP and growth in GDP, primarily because that is the metric that is used to discuss and describe the policy objective of economic growth. It's always growth in GDP that is being referred to, and therefore I thought, and I still think it's very important to consider what happens or what could happen if we didn't have growth in GDP. Of course, it's really that we want a reduction in throughput. That's the main question, and I think when it comes to policy objectives, that has to be one of them. But for the purposes of this discussion today, this presentation today, and consideration of the steady state, I'm going to be emphasizing GDP. Now, when I designed Logra, I had in mind a specific question. And the question that I wanted to try to answer is, can we have full employment, no poverty, fiscal balance, and reduced greenhouse gas emissions without relying on economic growth? Now, there are many ways in which you can design a model in order to address a question like that. I was inspired by the work that had been done over the last 40 years, I suppose, to model the world system. J. Forrester's book, published in 1971, on world dynamics. This was followed a year later by the much more well-known Limits to Growth book, which was backed up by extensive research, and you can find descriptions of their modeling assumptions in that background work. Then, 20 years later, the same group looked at where things stood and argued that the indications were that we'd gone beyond certain key limits. And then there was the 30-year retrospective in 2004. And the analytical apparatus used for all of these studies was system dynamics. So for those of you not very familiar with system dynamics, turning to the next slide, I have here a representation in STAT, which is a software program for developing system dynamic models of population. It's a very simple model, but you'll see that it's quite powerful. In the center of the model, we have population, shown as a rectangle, which represents a stock of people. And the population is added to by births, and births are calculated simply as a multiplication of the birth rate and the size of the population at any point in time, and that's why there are arrows going from population and the birth rate to births. And meanwhile, the birth rate itself is dependent in part upon the size of the population. And so you have there a positive feedback loop. As population rises, multiplied by the birth rate, you get an increase in births. You can allow that to be a more complicated relationship, because it could be that as the population rises, the birth rate tends to come down, and so the strength of the positive feedback is somewhat less than it would otherwise be. Then on the other side of this, we have deaths which deplete the population. It's basically the same logic, that deaths are calculated as a multiplication of population and the death rate, and the death rate itself can be assumed to depend upon the population. And that gives us a negative feedback loop, so that it's the relative strength of these two feedback that determine what happens to population. So that kind of relationship between stocks and flows, feedback and nonlinearities is fundamental to system dynamics and becomes incredibly useful for understanding possible trajectories for an economy in such a way that we can also relate that economy to some of the main links to the biosphere. So in the next slide, I show a structure of the model Logra. So let me just take you through this. At the top, we have macroeconomic demand, which is defined in the very conventional way that as the sum of consumption expenditures, investment expenditures, government expenditures, export expenditures minus imports, because of course imports are part of somebody else's gross domestic product. The model also contains an expression to explain how gross domestic product is produced by some combination of capital and labor, and the T variable, time, allows us to take into account how productivity can change over time. And so what happens in the model is that money is spent in macro demand, And then that determines the requirements for the use of capital and labor to produce whatever it is that is being purchased. And so this macro supply function estimates the employment level and the capacity utilization rate consistent with any level of macroeconomic demand. But there's also another very important relationship in Logra, and that is that the investment in macro demand, that I variable, adds to the capital stock, which determines the capacity of the economy to supply what people and everybody else wants to buy. And so what happens over time is that as you have investment expenditure in the current period, which has a big impact on employment, it also adds to the capacity of the economy in the future, requiring even more expenditure, not just investment, but possibly in all of those categories in macro demand, to keep maintaining employment and capacity utilization at acceptable levels. And that kind of relationship is certainly captured in the model. As well, there is a demographic component in the model which can affect consumption, but it also affects the labor force and the labor component in production. And so again, we have connections here which are really important for understanding the dynamic of the system. As population grows, the labor force grows, the capacity to produce grows, you need to keep expanding GDP simply to maintain employment levels. At least that's the conventional wisdom. The model also keeps track of the government's fiscal position. That's all governments in Canada added up as if they were one, federal, provincial, and municipal. And it keeps track of the numbers of Canadians living below the poverty line, and it estimates greenhouse gas emissions and has a forestry subcomponent as well. So that's the basic structure of Logra. If you go on to the system, which is, by the way, available on the internet, as the high-level structure of Logra, which is generated directly by the model. Each of these boxes refers to a component in the model to work on the item that's stated there. So you have consumption, investment, government expenditure, and foreign trade. Then, in addition to that, as I've explained, we have that production function sitting right in the center, which takes total expenditure and estimates employment, which you can see there. We also have the capital stock, the capital utilization rate, and population and the labor force. Then we have components in the model which allow us to look at, on the right-hand side, the redistribution of income to deal with poverty, the fiscal record of government, which includes government expenditure and income. Government income is shown explicitly there, but government expenditure is also included in the model right at the top. And then there's a box for the performance indices. So there we have not just GDP and GDP per capita, but we have the Human Poverty Index and greenhouse gas emissions, and one or two others as well. And finally, you'll see there the Human Poverty Index, greenhouse gases, the forestry model, energy use, a carbon tax, and so on. So each of these has its own little place in the model, and you, I think, can appreciate that to understand how they all interrelate is a Herculean task for us to try and do mentally without the assistance of a computer system. And to emphasize that point, here's the linkages among all of these different sectors. And each of these red lines, by the way, is a bundled connection of individual links. So you can see it, for a simple model, it can become complicated quite fast. The next slide shows the interface that the user looks at when you operate the model. Each of those green rectangles at the top are in fact buttons that allow you to control the model. So you can produce the summary results, you can look at detailed tables of data for GDP, the fiscal position, poverty and forestry. Then there's access that you can get to controlling the model, economic controls for different scenarios, and the social and environmental controls for scenarios relating to income distribution and environment. You can run the model, there are instructions, and you can go to a welcome page. I'll show you some results in a minute. But I want to dig a little deeper into the underlying structure of the model so that you have as good an idea as I can convey in a few minutes as to how it functions. And I'm going to use the capital sector in Logra as an example. The capital sector is in which the capital stock of the economy accumulates. You can see here, we can start, it's very simple, that you have a stock of produced assets. That can be infrastructure, buildings, equipment. It's added to by gross investment in capital, and it's subtracted from by depreciation and demolition. And then we can see what determines the gross investment in capital. Well, it's a combination of a couple of categories of investment: private business investment and government investment, which, when we add them together, gives us total investment. And then we have a further parameter in there, investment growth, which is very useful for, if you like, overriding the business as usual assumptions that come from the model, so that we can explore implications for lower levels of investment that might be required to achieve a steady state economy. Then on the left-hand side, we have the determinants of depreciation and demolition. Simply, we have a relationship of the depreciation and demolition factor and the amount of produced assets, so a certain percentage every year are assumed to be demolished, and so that subtracts from the amount of produced assets in the model. Then you'll also see at the bottom an arrow that links depreciation and demolition to gross investment in capital. And what that does, it just allows us to say that investment not only accounts for new investment, but also has to replace what's worn out. Now that simple model actually performs quite well when we compare the historical record from 1976 to 2006, which is the red line of business investment expenditures, and the blue line is the one that comes from the model with the equation for estimating investment illustrated below. It simply says that investment goes down when the interest rate goes up, it goes up when GDP goes up, and it goes down when corporation profits tax goes up. And each of those variables is lagged by a year. So now, what makes an economy grow? Well, we can look at this from the point of view of macro demand. It's what we spend our money on. We spend it on consumption, on investment, that's new infrastructure and buildings and equipment. Government expenditure on goods and services counts as part of GDP. And then if we run a positive trade balance, that adds to GDP, and a negative trade balance subtracts from it. So we can look at all of those things and see how growth is affected. Then we can look at it from the supply side, and we see that the capacity of an economy to produce depends upon its labor force, its size, its skills, the extent to which it's employed, the capital stock, and a whole host of factors that affect productivity. And all of those are represented in Logra. Now, when we run the model to create a business-as-usual scenario, saying what would the Canadian economy look like, broadly speaking, if it ran from 2005 to 2035, much as it had done in the previous 30 years, we see the following. And what this graph shows is that if we just were able to repeat the trends of the previous 30 years, GDP per capita in Canada would rise steadily. It would approximately double over that period. Greenhouse gas emissions would also rise, but not quite so fast. Unemployment would go up and come down again to pretty much its level in 2005. The government's debt to GDP ratio would decline steadily. Canada was running quite a significant surplus in 2005. But sadly, the Human Poverty Index, which is the UN's Human Poverty Index, would rise over that time, telling us that there would in fact be more Canadians poor at the end of 2035 than in 2005, even with all that economic growth. Now, that's largely due to the fact that we're expecting some population growth. But to think that the economy will be twice as rich in 2035 if we have a business-as-usual scenario, but poverty is no better. In fact, by the absolute terms, it's worse. It's not a very happy outcome. So then I used the model to ask the question, what happens if we eliminate all of the increases in all sources of economic growth, starting in 2010, and eliminate them steadily over 10 years? And there's a list of all of the growth factors which I reduced to zero. Now, you might expect it to be disastrous, and that's exactly what the model displays. You see that unemployment has gone off the graph. The government's debt to GDP ratio, the red line's also got completely untenable. GDP per capita eventually has stabilized in the 2030s, and greenhouse gas emissions have come down, but poverty, of course, has gone way up, largely because of the unemployment. Well, I wasn't the only person, I'm glad to say, thinking about whether there were alternative ways to run an economy. And right in the middle of the financial crisis, Larry Elliot, the economics editor for The Guardian in the UK, made the statement that the real issue, it's not the financial crisis, but it's whether it is possible to challenge the growth at any cost model and come up with an alternative that is environmentally benign, economically robust, and politically feasible. Well, you can certainly model such a scenario using a model like low growth. So here's an example of a better low or no growth scenario. Now you'll see, I did the same thing here, I should say. I've introduced a number of measures which I'll describe in a moment, starting in 2010 and phasing them in over a 10-year period. And towards the end of this overall period, starting in about 2030, you can see that GDP per capita has in fact stabilized. Greenhouse gas emissions have come down, unemployment is way down, lower than we've seen in Canada for at least half a century. The poverty index has come down, it's very low compared to other countries in the world, and still the government's debt to GDP ratio has declined and is quite healthy. So how did this happen? At least, how did it happen in the model? Well, it was a combination of things. I'm going to give you a list. Some of them are modeled explicitly, and some I put on the list because I think they're complementary measures that would also be important. The first is we need new meanings and measures of success. As I said earlier on, I use GDP because that's the metric that is used so often to discuss the state of our economy and GDP growth. But that's not good enough, and clearly we need more than that and other measures. We need fewer status goods. If we're going to stabilize GDP, it means we've also got to stabilize its main component, which is consumption. Consumption expenditures are in significant part driven by a desire for status. It doesn't work overall because we can't all raise our status through consumption. And so we need fewer status goods, which means we've also got to address that tricky subject of advertising. Fundamentally, I think we have to place limits on material, energy, waste, and land use to control the overall impact of our economies on the biosphere. In the scenario that's before you, the population is assumed to be stabilized, as is the labor force, by the end of the period. There's a carbon price in the model. That's fundamental for reducing greenhouse gases. And of course, a carbon price would make all prices more informative because to some extent all products and services use energy, and so their relative prices would be presumably affected by a carbon price. We need a more efficient capital stock. I haven't said much about technology, but clearly technology has got a lot to offer to us, but because of the rebound effect or the Jevons effect, we need to have absolute limits on materials and energy. Otherwise, efficiency does not deliver reductions in the absolute use of materials and energy. Unemployment comes down in the model because I've included a shorter work year, so that the amount of work is divided up among more people, and that's why the unemployment rate can be reduced so significantly. There are more generous anti-poverty programs that are included in the model, and they're all costed, they're all fed into that calculation of the debt to GDP ratio. And so that's very important for bringing down the poverty index. And finally, I work in the education sector. I'm very aware that the way we conduct our activities have to be broader than just trying to educate students for work. We have to do it for life. Let me just say something about this reduction in the average hours worked. This next slide shows the average hours worked per employed person in Canada from 1961 up until 2007, and you'll see that at 2007 it had been reduced to an average of 1,736 hours per year. In the scenario I just showed you, I simply projected the same trend that we saw in the early part of that period, from about 1961 to about 1980, forward to 2035. That would bring us down to 1,500 hours per average employed worker in Canada. Is that realistic? Well, if you look at what the average work year is already in 2011 in some European countries, it's already below 1,500 hours on average for a worker. In the Netherlands, it's even below 1,400. So it's certainly a plausible scenario in that regard. Now, Now, these ideas, I'm glad to say, have begun in a small way to enter the mainstream. Here's Robert Solow, Nobel laureate in economics, who wrote, "It is possible that the US and Europe will find that either continued growth will be too destructive to the environment and they are too dependent on scarce natural resources, or that they would rather use increasing productivity in the form of leisure." It's a very nice summary of the scenario and rationale that I've just described. Now, in his article from which this quote comes, he goes on to say, "There's no reason at all why capitalism could not survive with slow or even no economic growth." By the way, I wrote to Solow just to confirm that he really did mean what he said in the quotation, and he did confirm as such. Now, let me just bring you a little bit up to date, because the work I've described now is getting on for almost a decade old. In October 2010, this character here, who wrote this book, met up with this person, Tim Jackson, who I hope you've heard of, who wrote this book, Prosperity Without Growth. I wrote Managing Without Growth, and as he has been known to say, we were probably the only two authors who put without growth in the titles of our book. And so we decided at a very nice dinner in a restaurant in London to collaborate on a new model, which we have called Gemma. Very briefly, because Gemma is still a work in progress, so I'm glad to say it's nearing the end, it's more ambitious than Logra in many regards. It includes the real economy, where labor and capital are combined to produce goods and services. And it's true to the traditions of ecological economics, which understands that the real economy is embedded in the biosphere and requires energy and materials and life forms, if you like, to run the real economy. But we've also drawn heavily on modern money theory, which has focused on the relationship between the financial sector and the real economy. And what we've tried to do in our modeling is to put all these three together in one coherent system. We've continued to use systems dynamics, and the next slide shows you in the background, you're not supposed to be able to read that, but that we're still using systems dynamics to represent this now much more comprehensive system. And some of the features of Gemma, which I'll run through very, very briefly, are as follows. It's comprehensive, it uses systems dynamics, it has stock flow consistency, which means that we keep track of all stocks and all flows, particularly in the financial system. And some of this work has been done in Australia by Bill Mitchell and colleagues, and by others around the world. So we've found that incredibly useful for understanding the macroeconomy, particularly in its financial dimension. Our model is data-rich. Everything we do relies upon access to the best and fullest data sets that we can find. We use multiple performance indicators for judging how well the system is running. And expectations are modeled endogenously. In other words, we don't assume that decisions are made based upon full knowledge. They're based upon people's expectation about the future, and those expectations are formed as the model plays forward into the future. And we also allow different assumptions about how people behave. On the financial part of the model, we have a complete set of balance sheets and flow of funds accounts, which links the balance sheets together. Money we assume to be produced endogenously by the commercial banks within the economy, again reflecting the teachings of modern money theory. For the real economy, we don't just have one sector, we have a 12-sector integrated input-output sub-model. We allow the work week to vary, and we allow labour productivities in each sector to vary, because that can have implications for a steady state. And then we have demographic and housing submodels. For resources and the environment, we have resource and environmental flows, the size of which depends upon what's happening to the real economy. And we allow investment to both affect regular infrastructure, but also infrastructure designed specifically to reduce the burden that the economy places on the environment. Now, models of this sort, let me say in my closing moments, do not predict the future. That's not our intention at any rate. But I think they can be useful for scoping out possible options and for informing public discourse and policy debate about what might be possible. It's clear to me and to many others, and I'm sure to many of the people in the audience, that we have to make some big choices. The time has come. I hope it's not that the time has passed. And my last slide shows a representation of the kind of choice that has to be made. We can still strive, if we so wish, for more economic growth. And I do believe that if we do that, particularly in the conventional way economic growth is defined and what we do in order to achieve it, we will pay a heavy environmental and ultimately social price. Or we can make a choice to find a path towards what in this picture is shown as sustainable progress. However, I want to say that an elderly person is the one shown in this picture, and as the time passes, I'm afraid to say I look more and more like this person, that we're not the people to make this choice. We perhaps have done something to help understand the choices that have to be made, but these choices will have to be made by much younger people, many of whom I hope are assembled here today, and I wish you all the best in your deliberations. Thank you very much.